The package has just arrived. I'm going to open this. Ooh. Now you're going to notice I've ordered 20 of them or so. The reason is it's actually cheaper. You order 5 of them, it's like $5.20. You order 20 or 30 of them, you find out when the boards are this small, you find out you can actually get them for like $4 for a package of 20. So that's what I did. Shipping was through DHL, and the boards took 6 days from submitting my files to getting this. And now let us zoom in and compare. And they board sizes look about the same. And the thickness looks correct. I ordered 1mm thick PCBs because they need to fit into the slots in the housing here. If anything, it's slightly loose. Yeah, that fits fine. Alright, so fit-wise, it looks pretty good. You can see here's the connector side, right? Flip it over. We've got the microcontroller, the ground, and power from the battery come in. And you can see there the pads are sort of cut in half, these half circles, and the holes in the middle that go through the PCB, they're plated. They're plated through holes that are on the edge of the PCB. Those are called castellated holes. And those, if I put them on this board, would have cost me $36. So I just moved them inside slightly over here. And while they're not in exactly the same place as where the stock ones were, that will be fine. So all this is going to do, as I think I've already explained it, is I'm going to put just a little AT-Tiny 85 microcontroller there. And all I want to do is control the blade data pin, which communicates with the blade and tells it what color to turn on as and when to flash. And one of the LEDs, the LED that's in the base of the kyber crystal chamber. Yeah, so this looks relatively good. I need to find my connectors now and throw the connectors in, add a transistor, and I may just have to assemble one. But first I gotta go find all the components. So it's been a few days since the PCBs arrived. So remember, this is to replace this, which is broken. But also arrived today is another thing that's made things interesting, which is this. This is a Logic Pcb from a Savi's workshop that's known to be good. This was kindly sent to me by somebody who is modifying theirs to replace the logic board with something else, and they sent me their logic board to replace my broken logic board. So, very interesting things, but I'm very grateful for this. This is what will be going into my lightsaber when I am all done with this. However, I have started this project, and I'm going to see it through to completion, or at least partial completion. We'll see. Alright, I want to start assembling one of these. I want to put it together in stages. The plan here is to first put the voltage regulator on and a couple of components that support it, and then hook it up to my power supply here and just make sure that I'm getting 3.3 volts out of it. I think what I'll do first is put the voltage regulator on. So, make sure I've got some flux here, good. And I am going to start by tinning my iron. The flux in the solder helps to remove any oxidation off of the tip, so it'll transfer heat better. Now I just want to tin one pad here from the location where this voltage regulator is going to go. Good. Alright, so now I need to get the voltage regulator out of its tape reel here. And that's going as well as I expected it to. So I'm just going to set this down, and I'm going to reflow the solder on that one pad. and that's a little out of alignment, unfortunately. Did I get that? That looks lined up. I'm just going to check it from the side, make sure it's not sticking up. That looks good. Okay, awesome. So now, more flux. Again, flux. I really need a new pen. I've ordered one because the tip is destroyed. I'm very brutal on my flux pens. I really don't need much. If I connect two of these pins with the iron and one pin has solder and the other pin doesn't, solder will actually flow across the iron to the other pin. So I only need just a little bit of solder on one pin, and then I can carry the solder across to the other pins. So I've got one more pin left here, which is the other pin on this side. Next we have those two capacitors, C1 and C2. So that is one of the pads for C1. And that's a pad for C2. Same deal as the voltage regulator. I'm just going to reflow the solder on that one pad that I tinned, and hopefully not play with it too much, because as you see I just wind up sending it across the table. I want it to lay flat on the board. That's why I keep, after I have it connected, after the solder has formed a connection, I keep going back and reflowing the solder, trying to get that capacitor flat against the board. And I should have put some more flux on the pads here, on the capacitors, now that I've got one side connected, and I didn't, but that's fine. There's flux in the solder, which will take care of things. That is all we need. R1 is a resistor that pulls the enable pin down to ground. The datasheet for this voltage regulator does not specify that that should be there. I added a place for it just in case I do need it. That enable pin that turns on the voltage regulator is going to be tied to the crystal insertion switch. It's a switch at the top of the crystal chamber in your Savi's workshop lightsaber hilt. And when it presses, it sends a signal back saying that the switch has been pressed, and the stock logic board detects that and starts scanning for an RFID tag in the crystal. I'm going to use that here as the power switch. So when you put a crystal into the lightsaber, that will enable the voltage regulator, which will power everything else on this board. So when the crystal is out, power is removed from this board. So in theory, it's not going to draw much, if any, current when it's off. Hopefully saving the battery pack a little bit. That's the theory. But because I'm in the beginning here, I'm testing, I don't have that crystal switch connected through one of the ribbon cables here. So what I've added here is this program header here, and I'm going to put a switch in there that lets me connect two of those pins that's going to pull that enable pin high. I mean, you can even follow right here. That middle pin comes all the way over here to that R1, over to the enable pin on the voltage regulator. So what I need to do is put a switch in. This is the switch that I have in mind. Is that going to be in the way? That is almost certainly going to be in the way of this. Let's find out. You know what? I think I have space. I think it's going to fit. You can just sort of see it right here. I think I may have gotten away with one there, purely by accident. Let's put that on. Okay, I've decided I'm going to mount the switch upside down, like that. It's just, I've got more space there. Less chances of running into problems. Again, I did not think this part of it all the way through. This is why you prototype stuff. This is why you only make a few of these PCBs the first time through, to get a sense of whether or not it will work. Come on. come over here and make sure it's flat enough. Solder the other 2 pins into place. Little solder splash on my finger. Ow. There we go. There's the programming, or what it really is the voltage regulator enable pin. Alright, so I've got the green and blue wires providing power to the board here. Right now, it is outputting nothing. I'm going to turn it on now. And I see no heavy load. I see 0 load on the power supply here, so that's a good sign. Nothing's blown up yet. I'm going to come in here and measure with my multimeter here, and down here, even though it's out of focus, you should be able to still read what it says. 4.49. So 4.5 volts coming into as expected. Now I'm going to keep that on ground, and I'm going to go over here to the output pin of the voltage regulator, and I get nothing, and that's good because it's not turned on. I'm going to flip the switch now, and now we'll take that measurement again. 3.3 volts, so the voltage regulator is working. And then when I turn it off, that's just the capacitor, because there's no load. That's the capacitor draining. That's why the voltage is going down, but it goes down to 0 volts. Okay. So that part is working. What's next now? Alright, so we know R1 does not seem to be necessary, so I'm not going to populate it. I do need to populate R2 and Q1, which is the resistor to the... R1 is the resistor to the base of the transistor. Q1, which is going to be used to drive the LEDs in the... one of the LEDs in the bottom of the crystal chamber, so that it lights up, so I know I have some way of letting me know that everything's powered up and turned on and everything. Okay, let's do this. Actually could use a tin real quick because the iron's been sitting around. Good enough. Bring in the resistor. Fiddle with it, even though it's in a perfectly fine location already. And notice I didn't use flux at all, because flux, although helpful, is not necessary because the solder already has flux in it. But it definitely makes things easier. Okay, that's the resistor. Okay, I'm going to, like everything else, I'm just going to pre-tin one of the pads, like so. Come on. Reflow it again to make sure the transistor is flat against the PCB. Double check, it is. Good. Solder the other 2 pins. See, like that right there is a massive blob, but that's okay. It's not going to hurt it. I don't need to do anything about it, but if I want to, I can bring my iron, let some of the solder wick onto the iron, wipe the iron off, and repeat a few times until you get a slightly smaller blob. See? Works perfectly. Okay. Next up is the microcontroller. So, just like every other time, I'm going to pre-tin one pad. Bring in the microcontroller root chip. Make sure that the pin 1 indicator, which is that white dot there, matches the pin 1 indicator, which is that that divot in the surface of the chip there. And try to align this as best I can. Really don't need to be fidgeting with this that much, but again, I do all the time. Is that flat against the board? It looks a little lifted on one side. I'm going to use my finger to push down this time. Are those pins off the ground? No. Nope. I think it's just a weird thing. Just the way that it looked in the camera was weird. Okay. I'm going to bring in the solder for this, the flux for this. I'm just going to put a big old blob of solder on the iron and drag it down. And it's not going to work at all, this drag soldering. Why did I try and do this? Why did I try and do this? This isn't working at all. Well, I'll have to fix that in a minute. Now let's do it the less destructive, or the less show-offy way of just doing it one pin at a time. So doing the same thing I did with the voltage regulator. I'm using the iron to sort of connect two of these pins together, so excess solder on one pin will flow across the iron to its neighbor. And that side looks wonderful. There might be a little excess solder on a couple of those pins, but that doesn't matter. But the other side, where there is a massive bridge between two pins, that needs to be solved. How do we get rid of bridges? Well, you got a bunch of options. You can try to use a bunch of flux and reflow it again and hope the bridge goes away. Which is not happening in this case. I think part of the problem is that's a ground pin. Okay, if I want to play it that way, that's fine. Bring out a little copper braid. This is a solder wick. It's copper braid infused with a little bit of flux. What it does is you put it over the area where you want to remove some solder, and the solder will be wicked away into the copper braid. In theory. There, that looks better. No bridge anymore. Okay. I've never done this before. Tried to solder these type of connectors. I have no idea how this is going to go. So we are going to discover together how the heck to solder these things. There's two approaches here that I see. I could try and put solder on the pins first, and then after the pins have been connected somewhat, put the pads on either side that hold it in, solder those in place, and then go back and clean up the pins. Or start with one of the pads. I guess I'm going to have to start with one of the pads. I'll pretend a pad. Big heaping amount of solder, almost too much I'm sure, but oh well. Those pins look slightly off of alignment. Wow, those actually look like they're lined up. Huh. Did I pull that off on my first go? Okay. Okay, so I just got stupid lucky. Okay, so then I'll do the other pad. Okay. A little extra flux. And I'll just bring the iron in and hope. Let the flux do it the job. Because I can't do these pins individually. I'm going to have to just sort of drag solder in a way. Unsurprisingly, there are bridges. Hang on a sec. I'm trying to figure out how to hold the wick and the iron in a manner that's going to allow me to do this comfortably. There's going to be a bridge in the middle. That's because the 3 LED pins are all wired together anyways, so I'm not worried about a bridge on those 3. That is intentional. Just really want to make sure everything else Alright, how does that look to you? I don't know. I'm going to take it off the vise and inspect it real quick with my eyeballs. How much do I want to tempt fate? A little bit, not at all. Because I can come in here and try to wiggle individual pins coming off of the connector here. Just to confirm that they are soldered in place, and if I see one wiggle out of the way, they look like they're all connected. Somehow that, I think, worked. Oh, do I dare put the other one on right now? Because there's no way I'm going to be able to keep this luck going. Be in a position that's comfortable to you. And I've got a camera hanging over me that's in the way of everything, and I've never done this before, so I don't know what I'm doing. I know that's too much solder. Oh well. Alright, so this is going to come up like so. Yeah. 1 minute. With the Ignite PCB hooked up, I have some code uploaded to the microcontroller on here that will, whenever it detects the presence of a magnet through this Hall effect sensor switch, it should turn that LED on. And this is where we discover I should have been testing before I ordered the PCBs. I'm going to turn it on, and you see the light is on, and if I bring a magnet anywhere near it, it does nothing. The magnet, by the way, is out of an old hard drive. That's why it's got this big metal shield around it. The little crescent part is the magnet itself. Anyways, so how do we fix that? Well, here is what I discovered by accident. I need a pull-down resistor. I need something to pull the pin that's receiving that signal down to ground. And if I put a 20K resistor here between the SCK pin of the programming header, which is also the pin used to read the Hall effect sensor, and ground like that without it touching anything else, just jury rig it like that. Power it back up, and it's gonna, there we go. Now it works exactly as expected. So I need a pull down resistor. Oops. So, yeah. In the end, I opted to just take that through-hole 20K resistor and wire it up manually that way to the ground pin on the IC, which is pin 4, and the SCK pin / ignite switch pin, which is pin, 7. I tried a few times to get a surface mount resistor across there. The 0603 is just too small, I think, and the fact that this is a ground pin, and I wanted to keep the holes open, it just became a problem. So power is to the board right now. That bodge is in place. Here comes my magnet, and you will see the LED now. Oh, let me turn this down a bit. Hopefully you can see that now. That light is turning on. And if I take my finger and put it near it, or on the PCB, it also turns it on. I believe that is my finger coupling the 60 hertz mains AC line frequency stuff that's floating through the wires in the walls through to the board, triggering that to turn on as well, I think. But anyways, that works. I'm trying to get this all in one shot, and it is just not working at all. Anyways, I have power going to my logic board, new code in there that detects when the blade has been inserted and it's turning on the light. I remove the blade, the light current turns off. Insert the blade, the light turns on. So the blade detection is now working. But I discovered another design flaw with my logic board. Here is the Logic Pcb, and the first bodge I had to put in here was a resistor here to pull the signal from the Hall effect sensor that tells it whether or not the blade has been turned on. I needed to add a resistor to ground to pull that pin low until the signal turns on to pull the line high. The same exact thing is happening with the blade data pin. To detect when a blade has been inserted, I need a resistor to ground, which this little pad here on this unpopulated resistor goes to ground. I need a resistor to ground to pull the blade data pin to ground as well. I did some experiments though. This is a 20K resistor, and 20K is too low. I needed at minimum a 220K resistor to pull this signal low to the amount of current coming from the blade to let the microcontroller know that it's there is very, very small. So I need a very high resistance, just enough to pull the pin to ground, but not enough to pull all the current coming from the blade to ground as well, which is what was happening with the smaller resistance. All the current was going through the resistor to ground and not going into the microcontroller, so the microcontroller didn't see the signal from the blade. I needed this 1 mega ohm resistor here to do that. So it's pulling that pin to ground, but it's not going to suck a lot of current through it to ground. It's going to allow the current coming from the blade to still go into that microcontroller there. But for now, as an exercise in getting this thing up and running, this will work. So there we go, second bodge. Hopefully that's all I need, because it's the data pin and the blade detection pin. Those are the only two input pins here for the microcontroller. So those are the only two pins that are going to need these pull-down resistors. Everything else should be fine. Knock on wood. So what's next now? The next thing to do is going to be to, when it detects that the blade is there, to then when it detects the switch, to turn the blade on, to remember the state of the blade, what color it is, to turn the blade off when the signal goes away. So I need to create now in the code a little state machine and put all of these inputs into it, and then hopefully I'll have something. When you turn it on, it ignites the blade. When you turn it off, it turns the blade off. When you turn it on again, it goes to the next color and it rotates through the whole set of colors. That's the plan. Hopefully it'll work. I have finished writing the code to turn on the blade when the switch is activated. What I am going to do here is I have an old Arduino Uno here set up as my programmer. I'm going to use this ICSP port here that is, well, let's zoom in. That is the in-circuit serial programmer, which I've got wired up here to these DuPont pins here like so. And what I'm going to do is I'm going to put the connect the pins, and the holes here are plated vias, or they're plated through the hole. So if I just put a little tweak of force here to this connect to these these pins while they're in the hole like that there, it's enough to make a connection and I can program it. So I've got this hooked up. I'm going to program it now. I'm going to come over here to the Arduino and I'm going to hit upload. There we go. And it's because I am on the wrong COM port. That's okay. I can go to, what is it, Tools, Port, and I'm on COM 7. So I'll go down to COM 7. Let's try that again. It's uploading the code. I see lots of blinking happening, and it says done uploading. So in theory, the code has been uploaded to this. So I can take the Arduino Uno away for now. Now I need to hook this up to the lightsaber, the chassis. So first I need to bring the sensor switch back. And where does that go? That goes on. There are two flat flex cable connectors. One points out, one points in. The one pointing in goes to the switch. So just put that in like so. And I'm going to use some tweezers here to grab either side of the little black plastic clip that holds everything in place and close that. Good. Now I need to hook up the actual chassis itself. This is power to the top side, to the blade that goes through this connector. I need to hook this up. The gold contacts on the flat flex cable should be facing away from the black plastic clip. That's how you know the orientation for the cable. And then try to finagle this so it stays in place while I try to close the clip. Like so. It is a good thing I am not a surgeon. There, okay. So now, what I'm going to do is I have my blue and green wires here. I'm going to hook these up to the bench power supply that I have in front of me, and I'm going to power everything up at 4.5 volts to simulate 3 AAA batteries. Just clip that on like so. Move those out of the way because we don't care about that anymore now. But not in such a way that they're going to short. Hang on a sec here. I just need to try and find a way to hold all of this stuff. Good enough. Okay. Power supply coming on. Output enabled now. And currently, no amps are being drawn. That is a good sign. No electrical shorts. So now I'm going to plug the blade in, and in theory, this light should turn on when the blade is plugged in. So here we go. Come on, there we go. And the light has turned on. That's a good sign. That's a good sign the code is working. Okay, I'm going to use this little sort of pin, those thumbtacks have this shape. But this one has a little neodymium magnet in it. I'm going to use this as my switch. The switch is triggered by this Hall effect sensor there, so I'm just going to bring this in, and in theory, that light should go out and the blade should ignite. Now it should, in theory, again, ignite white. Here we go. Oh my gosh, it worked. Okay, good. So now I'm going to take it away and it should turn off. Oh, and it animates and everything. Now this should start up a different color now. The idea is every time you switch it on and off, it'll change colors. And I've got some delays built in. I've got like a 1 or 2 second delay when you turn it on and when you turn it off. That's why when I take this away, it was staying on. Oh, it works. It actually works. Oh, that's wonderful. Okay, so we're getting to the end of the colors. It should cycle back to white, and it does. Oh, beautiful, beautiful. It works fine. Okay, now I'm going to try some interesting scenario. Oh, what happened? Did you turn off? Yes, you did. That's okay. Let's just find a bigger magnet. Okay, good. Now, I have... Wait, why are you not staying on? It's because the orientation of the magnet is such that it's only triggering the thing... Right, so where was I? The orientation of the magnet is what is when it's like this, it turns on, but when it's not on its side, it is in the wrong orientation and the switch doesn't work, so I need to hold it up on that side. Okay, I'm going to unplug the blade now, and it should recognize, again, that the blade is no longer plugged in, so nothing should happen. Just turns off, right? Now I'm going to plug it back in. Oh, and it's still sending the color signal. Okay. All right, that's okay. I need to... Oh, there we go. Okay, that did it that time. See, so now it knows the blade is plugged back in. Oh, because I had the magnet there. That's why it immediately turned on again, because I still had the magnet. Anyway, so it resets itself when you unplug the blade while the saber is turned on. That's all I was getting at. One more thing I completely forgot to test here. I have this little switch on the blade, on the Logic Pcb. This is like a bypass to enable the voltage regulator that's on board. I'm turning that off because I also have the enable on the voltage regulator going to this switch here that is in the crystal chamber. So the idea is that this thing will only power on if there's a crystal there. If there's no crystal there, it won't power on. I need to test that, so I'm going to plug the blade in here. So it's still connected power, still going to the logic board there. All right, I've connected that, and as you can see, there's no LED turning on there. Now, if I push on this, it should turn on. Oh my gosh, it does. And if I take it away, it turns off. There is your on-off switch for this thing. That is awesome. All right, so now if I hold this with one hand and bring in this with the other hand, there we go, and it ignites. Then I take it away. All right, I see one thing I want to add to the code, actually. I want this LED. Do I want that LED to turn on? It's a modification to the code I'll have to work on later. I want that LED to turn on and stay on for like 30 seconds after you turn this thing off, just so you know that there's power going in there. I want to ultimately, because right now that's just a hard on. It's the LED is always on. I want to PWM it, which means turn it on and off rapidly several times a second. But to your eyes, it's always on, but it'll be dimmer because it's actually not on all the time. That will save current, so that I can have that on longer without sucking up a lot of battery power. That is a modification, or something I need to work out in the code. but somehow this is working, and I am shocked. It's a day later. I have done some modifications to the code on this, just to add some effects with the little LED here that it's controlling. So when I power this on, it's going to do a little sequence with this light where it's going to blink a few times. It's similar to what would happen after you insert a crystal here. That way you know that it recognizes that you've inserted a crystal. So power on now. And it does a little blink sequence. Okay. And although I think I need to remove this now, because probably you're going to have, when you put the switch panel on, you're not going to be able to see this LED, but I added something where if you try to turn it on, it blinks at you to let you know, stop trying to turn it on. There's no blade connected yet, but I realize now that that little feature is not necessary because this panel will be covered up. Yeah. Okay. So the next step then is you plug the blade in, and again, I realize now, having spent the last few hours on this effect, realizing it's completely unnecessary, that LED, and you can sort of see it better in the reflection here, is fading in and out. It's doing like a little breathing effect. And it's going to do that for 30 seconds, and then after 30 seconds, the next time it fades out, it's going to stop the breathing and it's going to keep the light off. That's just to let you know that the blade is inserted and it's ready to turn on. I'm just waiting for it to finish its cycle so it turns off. There you go, so it turns off now. And you don't have to wait for that to turn off. You won't even see it, again, because you're going to have everything encased here. So that LED is serving no purpose doing that little effect. Go me. But there we go. We turn it on with the switch, and you can see over here it lights up, and it will cycle through the colors, and when it turns off, this little light will start fading again, breathing for 30 seconds and then turn itself off. And you can see when the blade ignites, that LED turns off immediately. And it works pretty well. I'm pretty happy with this. The realization, of course, that the effects that I've created for this little LED here are completely useless, but oh well. There are LEDs on the top I could have done that to. They're not wired up for that on this board. I'd have to redesign the board, but it'd be a tiny redesign. However, it's the same issue. You put the crystal in, you're still not going to be able to see those LEDs unless you don't have your whole chassis put together with all the metal pieces, all the scrap wrapped around it to make it look like a proper saber. Oh well. Okay, point is, everything is working. I am really ready here to just reassemble this. All right, here we go. The bottom end is back together. The RFID antenna and the speaker contacts, the speaker being in the base of the battery pack, are not connected. They're just in there because, well, the antenna is glued to the bottom of this piece of plastic, and that's needed to hold the crystal in place, so that has to be there. And the speaker contact wires, sort of the same thing. They're already attached to the battery contact PCB. Why remove them? So anyways, this is it. First time I'm trying it. I'm going to plug the battery in, and hopefully I'm going to see some lights blinking in there when I do this. And I don't, that's right, that's okay, because I don't have a crystal in there yet. But if I hold this button down with my finger, hopefully right here we'll see a light. Oh, excellent, we see a light, good. So I'm going to plug in an actual crystal here. And I saw it blink. Good. Now I'm going to put a switch in. Make sure it's in the off position. Now if I plug it, if I try to turn it on, it should blink again. And it does. That's letting me know that the switch is being detected and handled appropriately. So here we go. the exposure. Bring the light down a little. There we go. It lit up. Turned it off. Turn it on again. And now it's just going to cycle through all the colors. Yellow, green, blue, purple, and back to white. Awesome. So there you go. The custom PCB actually works. So the custom logic board is installed. We are running off of normal battery power. The whole lightsaber has been put together. The exposure has been locked off specifically so when I turn this on you can get a really good look at all the colors. And I'm just cycling through the power here, switching it on and off. And when I do that I get a different color every time. So if there's a special color that you want, you just keep powering it on and off until you get that color, and there you go. So that works. I am shocked that it actually works. This was a good experience. There's some stuff I still want to do with it, but I would say a big part of this little project is done.